Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is walls coloring, and it is a medium level problem. So in this particular problem, it states that we have been given n walls. So these are the n walls. For example, n is equals to 3. These will be the n walls, and like each wall can be painted in either three of the colors, that is pink, black and yellow. So you can choose any one color and paint that particular wall with that color. And we have to, like, there is a cost associated with each of the walls. For example, the first color has cost 14 for the first wall, the second color has cost 2, the third color has cost 11, right? So this goes on for all the walls. We have to find the minimum cost of coloring the walls such that no two adjacent walls are of the same color, right? So we just have to find such a configuration. We don't even need to find the configuration, we just need to output the minimum cost that is required to color all the walls. So let me just take an example from here. For example, this is the sample test case. Now 14 to 11, let us assume that this is the first wall, this is the first color, second color, third color, second wall 11, 14 and 5, and the third wall 14, 3 and 10. So for example, if I take this particular color for the first wall, then for the next wall, that is the wall adjacent to it, I cannot take this color even if it was minimum. In this particular case, it is not the minimum. I should always take this color because it is smaller. And then from the third wall, I will take this particular color. So the answer would be 2 plus 5 plus 10. 5 plus 3, that is 10. Right? But if this was 1, then I could not have taken 1 from here if I have already taken 2, because two adjacent walls should not have the same color. So this is a condition. Now this particular problem can be solved easily with DP. So we'll have to maintain a two-state DP in which I denotes the wall, and J denotes color of the wall. So for example, if I want to color the first wall with the second color, then I'll have my answer stored at the state dp of 1, 2. If we take 0 based indexing, it will be dp of 0, 1, right? So this will have my answer when I choose the second color for the first wall, and the rest of the answer is computed according to it, right? So this will have my best answer for this particular case, right? So what we can essentially do is, for example, for the first wall, I can check for all the possible colors. So let me just take 0 based indexing for better understanding, because this is what will be given in the question. The question will be 0, 1, 2, the colors will be 0, 1 and 2, and the walls will be 0, 1, 2 to n minus 1. So let us take 0 based indexing only from here right now. Okay, so if I have these walls 0, 1 and 2, for example, if I decide to take this particular colors 1, this particular color for my 0th wall, now the answer would be stored at dp of 0 and 1. What will be my answer? So the answer will be, first of all, I'll have to consider the cost of coloring the 0th wall with the first color, right? So this will be my cost, which will definitely be added in my answer. Plus I'll have to take minimum of, so for the next wall I cannot take this color. The only option I have is take this color or take this color, right? So my answer would be dp of, now for the next wall I'll have to increment this particular value by 1, and I cannot take the 1th color, so I'll take the 0th color, and for the same wall I can also consider the second color or the color at index 2 more precisely, right? So this is how we will form the answer for our current state of our DP, right? We just have to check we just have to add these two values. The first value would obviously be the cost of coloring the wall with that particular color, and the next value would be the minimum of the coloring the next wall with the colors other than the current color, right? So for example, if I was at 0, let us just write it again. If I was coloring the 0th wall with the 0th color, then I will have to consider this particular color and this particular color for my for my minimum answer, right? So in this case, dp of 0 0 would be equal to, first of all we will have to consider the cost, right? So we have considered the cost, plus we'll have to add the minimum of two values, and those two values will be, first of all I'll have to increment this value to 1 because I'm considering the next wall now, and I cannot take 0, so I'll take 1. I cannot take 0, so the next number that is left with us is 2, right? So this will be my answer or my result for this particular state, right? So we can calculate this for all the DP states. We can do it iteratively or recursively, any way we want. And at the end, what I'll do is, for example, if my answer is stored at 0, right? Because I'm computing it in a forward manner, I'm computing dp of 0 0 is equals to cost of something plus dp of 1. So I'm computing it in a forward manner. So my 0th index will have all the answers, right? But for the 0th index as well, I'll have to consider whether I color the wall at the 0th index with the color 0, with the color 1, or with the color 2, right? So my final answer would be minimum of dp of 0 0, dp of 0 1, and dp of 0 2, right? So my final answer would be the minimum of all these three values, because for the first wall I don't have any constraints. I can choose any of these three colors. So my best answer would be when I decided to color the first wall with the 0th color. So this is first case. I decided to color the 0th wall with the first color. I decided to color the 0th wall with the second color. So my best answer would be the minimum of all these three values, right? So let us just quickly summarize what we just said from here, from the DP states, right? So TP of ij will be our two-state format. I denotes the current wall and J denotes the color of the wall or the current color of the wall with which we want to paint the ith wall, right? So dp of ij will denote this particular thing, the total cost of coloring the ith wall with the jth color, right? Let me just repeat it again. dp of ij denotes the total cost of coloring the ith wall with the jth color, right? It's pretty simple, right? So how do we compute this? First of all, we'll have to compute the cost itself for painting the current wall with that particular color, painting the ith wall with the jth color, right? So after we are done with the current wall, we'll have to think about the next wall as well. So what we'll do is, we'll just add something to it, and that will be minimum of dp of the next wall. For example, in the current wall was 0, the next wall would be 1, and since I cannot take the jth color, I will take every number except j. So in this case, j was 1, I will take 0 and 2 instead, right? Similarly, in this case, if it was dp of 0 0, I'll have to first of all add the cost, right? Then I'll take minimum of two values. What should be those two values? I have currently done the ith wall, so next I should do I plus 1th wall, right? I have taken the jth color, so I'll take every other color other than j, right? So in this particular case, the current color was 0, the other colors left with us were 1 and 2. So these were the colors that we'll have to consider and take in our final answer. After we have computed all the values for all the DP states, my final answer should be stored in the total cost of starting from the 0th wall, right? But for the 0th wall also, I have three options to start with. Unlike the other walls, where we have only two options in each case, because the previous wall should have been colored with some of the color. Here we have three options, right? So I can color the 0th wall with the 0th color, the 0th wall with the first color, the 0th wall with the second color. So my final answer would be the minimum of all these three values, right? So let me just show you the code now. So this is the code, and what we initially do is we just initialize a DP state of n plus 1 and 3. So this is the I, this is the jth part, and for every of those colors I just mark DP of ni is equal to 0. So this is just like a base condition. Since I'm using iterative DP, I found this base condition for the nth wall because the nth wall doesn't exist. It's from 0 to n minus 1, right? So what we do is I just start from the n minus 1th position and I do it till I is greater than minus 1, and I just decrement I. So for each of those walls I have to look for all the colors, right? I set my DP of ij is equals to some big number which I believe will never get as an answer. So I just form it with the biggest number. Now again, this is the current color J. Now I have to look for the next color K for the next wall, right? If I have used the color J for my current wall, there should be some color for the next wall, right? Let us assume that the color is K. Now I have to make sure that J is not equals to K, right? Because the adjacent colors cannot be same. So DP of Ij would be the minimum of DP of Ij, comma, colors of Ij plus DP of I plus 1 K, right? So we have made sure here that the colors are not same. Let me just write it in the comment also. Adjacent condition to check that adjacent colors are not same, right? So we have made sure that the adjacent colors J and K are not same. So my DP of Ij would be the minimum of DP of Ij and colors of K, that is the cost of computing this particular wall with the jth color, plus DP of I plus 1. I plus 1 denotes the next wall and K denotes the color that we are going to use for the next wall. So this will be computing the DP of Ij for every of the states. Now since I'm depending on the next state, that is if I'm at wall I, I'm depending on the wall I plus 1. That is why I've made the first loop in reverse order, right? Because to compute the value for the wall I should also compute the value of the wall I plus 1 beforehand, right? So that is why I'm using the reverse loop in the outermost loop. So after all of this is done, I initialize my answer again with a very big number, and I just run a loop for 0 to 3, and I set my answer as minimum of answer comma DP of 0 I, right? So for the 0th wall I am considering every color, every start color, and at the end I can just return my answer. So this would be the solution for today's problem, that is walls coloring. If you guys were able to understand this solution, you can consider subscribing to this channel. It helps a lot, like it acts as a source of motivation. And that's it for today. Till the next video drops, keep coding, stay safe, bye bye.